Hi everyone, my name is Seon, and today we will be reviewing rational equations, and we will be solving question 20 from booklet number 7. So the question is 4 divided by x minus 2 times x minus 1 plus 1 over x minus 1 is equal to 3 over x minus 2, and we want to solve for x. So first off, what is a rational equation? A rational equation is really just an equation which contains at least one fraction whose numerator and denominator are polynomials. A good example of a basic rational equation is 1 over x is equal to 2. So in this case, on the left side, we have one fraction whose denominator is a polynomial. However, we can also have rational equations where on both sides we have fractions whose numerators and denominators are polynomials, as seen in this example, where 1 divided by x plus 2 is equal to 2 divided by x plus 3. We'll be starting by stating the restrictions. And the reason why we need to state the restrictions is we want to avoid cases where the denominator of any of these three fractions is equal to 0, as 1 divided by 0 or 0 divided by 0 are both undefined and will not give us a solution. So we want to make sure that we note these cases. So first off, we'll go from left and approach the next two fractions. In the first fraction, we see x minus 2 times x minus 1 in the denominator. So when we solve for x and x minus 2, we see that x is equal to 2. Additionally, for x minus 1, we see that x is equal to 1. So when x is equal to 2 and x is equal to 1, we know that the solution will be undefined. And for the next two fractions, we see that the denominator is also x minus 1 or x minus 2. So therefore, these two cases will cover those two denominators. And so, our two restrictions are x cannot be 1 and 2. For the next step, we will start off by multiplying by the least common denominator to simplify this rational equation. The way we'll do that is we'll look through left to right and find out what the least common denominator is first. As we can see here, we know that the common terms across each of the denominators are x minus 2 and x minus 1. Because for this fraction we have x minus 1, for this fraction we have x minus 2, and for this fraction we have x minus 1 and x minus 2. So therefore we'll multiply both sides by x minus 2 and x minus 1 to eliminate the denominators and solve the equation algebraically. So when we do this, we immediately eliminate the first fraction's denominator as it matches what we're multiplying it by. For the second one, since the denominator is x minus 1, we can eliminate x minus 1, and so we get 4 plus 1 times x minus 2, as that'll be carried into the numerator. For the right side of the equation, we cancel out the x minus 2 in the denominator, but we still have to multiply the numerator by x minus 1. So we get 3 is equal to x minus 1. So this is essentially our simplified equation. And now from here we will expand and solve for x. So when we expand this, we get 4 plus x minus 2 is equal to 3x minus 3. And from here we want to isolate for x, so we'll remove minus x from both sides in order to remove the x on the left side of the equation, which after simplifying gives us 2 is equal to 2x minus 3. And from here we want to eliminate that minus 3 on the right side of the equation, so we'll add plus 3 to both sides of the equation, which will give us 2x is equal to 5. And the reason why I flip the variable from the right side of the equation to the left side of the equation right here is because I want to essentially have the x on the left side, and we get x is equal to 5 over 2. Now that we've obtained a solution to our rational equation, we have to verify the solution by substituting back x is equal to 5 over 2 into our original rational equation. And we'll know it's right if the left side of the equation equals the right side. So we start off by substituting 5 over 2 into the original rational equation. Wherever we see x, we'll sub in 5 over 2 and we'll simplify and solve for that. And that therefore verifies our solution of x is equal to 5 over 2, since our left side is equal to our right side. And so we can verify and write our solution as x is equal to 5 over 2 and state our restrictions, which in this case are x is not equal to 1 and x is not equal to 2. So today I explained what a rational equation is. I explained how before starting to solve a problem, we need to state the restrictions for a rational equation. I showed how we multiply by the lowest common denominator in order to solve for the equation and get our solution, and explain how we solve algebraically to get a solution for a rational equation. Thank you for listening, and I hope you learned something.